All right, hey y'all, when you're writing code, you'll inevitably run into problems. Stuff that just isn't working the way you want, and this brings us to the topic of debugging. Okay, so here's what we're going to cover in this video. First, we're going to decode those scary red error messages. They're actually trying to help you once you know how to read them. I'll show you the simplest debugging technique known as printing stuff out. Every developer still does this, and don't let anyone tell you otherwise. Then we'll level up to breakpoints in VS Code, pausing your code mid-execution to see exactly what's happening. And we'll wrap up by looking at a handful of common bugs and messages that you're likely to see. Here's what nobody tells you. Professional developers spend more time debugging than writing new code. It's not that we're bad at programming, it's that code is complex and bugs are sneaky. The good news, debugging is a skill, and I'm going to teach you the techniques that make it way less frustrating. When an error, also known as an exception, pops up, there's usually a message, and that message has some structure to it. The first part, null reference exception, tells you what went wrong. In this case, you tried to use something that was null. The message, object reference not set, is computer speak for you forgot to create this thing before using it. This is gold. Line 5 in program.cs. That's exactly where your bug is. The error literally points to the problem. Let's think through some really common error types. First up, null reference exceptions. This happens when you try to do something with a variable that doesn't have a value yet. In more modern versions of C#, this is less of a problem because a lot of these nullability things are caught by the compiler. But if you've got a project that doesn't have null checks turned on, or you're passed a variable with a question mark after it, you have to worry about null ref exceptions. Index out of range exceptions happen when you're working with arrays and collections. Let's say you have an array with 5 items in it, and then you ask for item number 6. There's no item 6, so you get an index out of range exception. File not found and directory not found. These exceptions are pretty self-explanatory. You're trying to do something with a file or a directory in the file system, and it doesn't exist. When you're debugging, Console.WriteLine is your friend. It's not fancy, it's not elegant, but if you need to know where you are in the code or what a value is, it's super handy. Let's start with the idea of what this console thing is. This is a leftover idea from when very earliest days of computers. I guess the simplest way to say it is that console is the interface to a computer system. In the most simple sense, a computer takes input from a keyboard, does work, and then displays output on a display. You might have heard the term I/O before. That's input and output. If you want the computer to capture some data from the user, you'd do a Console.WriteLine. If you want to write something onto the display, you'd do a Console.WriteLine. So when something's not working, your most basic and brute force simple type of debugging is to print out a message. That message might be the value of a variable, or maybe just an indication of where the flow of execution went. If you add a ton of these Console.WriteLine messages to your code, it can get messy, which is to say that you probably don't want to leave all your Console.WriteLine debugging code in your app for forever. Here are some places you might want to put a Console.WriteLine call or calls. Drop in a CWL call perhaps at the top and or bottom of a method. That'll let you see what comes in and what you're sending back. Another place is before some problematic line of code. If line 10 crashes the app and throws an exception, put a write line on line 9 to see the values right before the crash. Sometimes when you're making decisions using an if-else block or a switch statement, things can get complicated. And maybe the path through the app that you think should run doesn't actually end up running. Not sure which branch your if statement is taking? Put a write line in each branch. Mystery solved, maybe? Breakpoints are a debugging feature that starts to get you beyond just simple Console.WriteLine stuff. The idea with a breakpoint is that it establishes a place in your code where execution should stop and wait for you to use the debugging tools to kind of take a look around at what's happening. Setting a breakpoint in Visual Studio Code, or the full version of Visual Studio, is super easy. The first step is to find where in your code you want to stop. This screenshot that you see here is from VS Code. In the left side of the editor, next to the line numbers, there's a space in the left margin. Hover your mouse there. You'll probably see a tooltip that says click to add a breakpoint. Click. That'll put a dot in the margin, and that's your breakpoint. Now run your application in debug mode. That dot you see there in the margin is the breakpoint. Now that you have the breakpoint, run the app in debug mode. When the thread of execution gets to that line, it'll stop and look something like this highlighted row. Once the breakpoint gets hit, you'll see some tooling light up. For example, in Visual Studio Code, this image here is the local variables debugger. This shows you the variable names and values for where you are in the code. There are a bunch of other debug tools in Visual Studio Code and Visual Studio 2, but yeah, that's a quick look at the local variables feature. Another thing you can do once you've hit your breakpoint is move through your code step by step in a controlled manner, and there are some handy keyboard shortcuts to help you out. Actually, I forgot to mention this one. Hitting F5 starts your application in debug mode with the debugging tools attached. This is keyboard shortcut for getting it all rolling. The F11 keyboard shortcut moves the execution forward by one line. If the next line is a method, it'll move you into the method so that you can start debugging the code of that method. But sometimes you don't want to go into the details of a method, and that's where F10 is handy. F10 helps you to step over the execution details of a method or property. So F5 to start debugging, F11 to step forward and optionally into a method, and then F10 to step forward but not drill into the details of the next statement. And those are the basic debugging moves that you can make. Some more debug controls. It's like we covered on the last slide. F10 runs the whole line, and F11 dives into method calls. F9 lets you add or remove a breakpoint on the current line, pretty much just the keyboard equivalent of setting or removing breakpoints using the mouse. The watch window lets you customize the variables you see in the debugging tools. Add variables to the watch window to track them as you step through. Super helpful for complex objects. The call stack window helps you to understand how you got to where you are. For example, if method A called method B and then called method C, you'd see that chain of calls in the call stack window. The breakpoint type that I've been talking about so far is just your basic breakpoint. Hit it and the execution stops. But let's say that you know that there's a bug at a certain point in a loop, something that happens on the 400th iteration. Are you going to really step through 399 iterations of the loop? No way. If you right-click a breakpoint, you can convert it to be a conditional breakpoint, meaning that the breakpoint won't fire unless a certain condition is met. If you wanted to stop on the 400th iteration of this loop, set a breakpoint, then right-click, and add a condition that says I equals 400. Hit F5 to start debugging, and the loop will run 399 times without you, and then stop before loop 400. Here's the overview of my approach to finding where a bug lives. First off, start with the error message. What type of exception? What line number? This narrows down your search immediately. Try to do it again. Can you make the bug happen consistently? If yes, you're halfway to fixing it. So try to figure out what has to happen to make the error show up. Once you've got an idea where it might be coming from, you can start making some small changes to your code. This is almost always an experimental process. Comment out certain chunks of code, add Console.WriteLine calls to print out messages, set some breakpoints and use the debugging tools. Ideally, this gets you to the point where you actually know exactly how and why the bug is happening, and that brings you to the last step. Now that you know where it is, you can fix it. Yeah, I know, easier said than done. Once you think you've fixed it, run it multiple times. Make sure you fix the cause, not just the symptom. So what if you've set a breakpoint and it's not stopping? Here are a handful of things to think about. First up, make sure you're running with F5. Debug. Not Control plus F5? Run without debugging. Easy mistake to make, and it means that the debug tools aren't even trying to help. Sometimes the breakpoint isn't getting hit because the execution of the code isn't working the way you think it should be. In this case, put a breakpoint even earlier in the code and start using F10 and F11 to step your way through the code. Sometimes the application is being compiled in release mode rather than debug mode. If it's in release mode, it's being compiled for production and probably doesn't have the supporting logic in the code anymore to do breakpoints. So double check that it's a debug build. Sometimes stuff just gets horked, irretrievably messed up. So try doing a clean operation against the directory tree that your code is in. That, theoretically, deletes the bin and obj folders and lets your build again from scratch. Sometimes that doesn't even work. If that's the case, close Visual Studio entirely and then go and delete any bin or obj folders. Restart Visual Studio and try again. It's frustrating in the beginning, but every bug you fix teaches you something. That frustration you feel when debugging, that's your brain building pattern recognition, In a few months, you'll spot these bugs before you even run the code. The bugs don't go away, you just get faster at finding them. So, wrapping up on our intro to debugging topic, don't panic at the red text of error messages. Read them carefully and think about what it's trying to tell you. Usually it's telling you exactly what's wrong and where, or at least giving you a hint for where to start looking. You don't have to get fancy. Print debugging using Console.WriteLine is a legitimate technique, and sometimes it's faster than setting up breakpoints. That said, learning how to set up breakpoints and learning the types of breakpoints that are available to you changes everything. Breakpoints let you freeze time and inspect your program's state. But overall, don't worry if you're not great at this in the beginning. It's all about practice. You'll get better at this. Every developer was terrible at debugging at first. In the next video, we'll talk about garbage collection. Garbage collection is really another way of thinking about managing memory. We'll explore how C# manages memory for you using the garbage collector. Anyway, I hope you enjoyed this video. Stay tuned for more. Thanks for watching.